Hey, good morning, Vaibhav. Looks like you and me are the only one in this session. Is there something wrong? Are people thinking that it will start a little late? Do you have any questions for me, Vaibhav? We can discuss that before the session actually starts. Okay, so your question is what are some of the real world scenarios where MapReduce would work? Okay, all right. S um, Before answering that question, Vaibhav, today, did you get the URL today link? All right. All right. So that means I have done everything correct. Okay. Some people are also joining. So talking about real world scenarios where MapReduce would work. So whenever the data starts growing bigger, let's take, I'll just give you the case study of what I did in earlier. So at InMobi, we had this massive amount of our web server logs. Web server logs capture which user accessed which URL at what time, from what IP address, and all the details of the about the that particular access. So whenever the user you are accessing a website is capturing some amount of information like what was the session ID, what was the URL, and what was your previous page, and your time zone. So all of this information is captured in the logs of the web server, and these logs are plain text files generally. Okay, so what I was doing is, based on these logs, and these logs were around 200 terabytes for me. So based on this log, I was building the recommendations for the user. Okay, so at InMobi, whenever you're playing a game or anything on your mobile, you generally fetch an advertisements from InMobi. Okay, you most lot of time you fetch the ad to be displayed from the InMobi. I mean, your app, the game, the um, various kinds of app fetch the URL from InMobi and display it inside the app. Now, okay, so to do that, I mean, and this URL we have already captured on the server side. So based on this, we were trying to figure out what were the game you were playing when your app has sent this request for the ad. Similarly, how many times did you send this kind of request to the server in an hour? Based on that, we were trying to predict that which user likes which game, which user prefers what kind of game. And based on this, so we prepared a big list of users and the games they played, and how much do they like that game based on number of times of playing and total duration of play. And so effectively, we were able to create this good mapping of who likes what game and to what extent. And based on this, we started giving recommendations to the user that you may like these games also. Okay. So, till the point of recommendation, all of this cleaning of the data, cleaning of all Apache logs, the web server logs, was done using MapReduce only. Okay. Because the logs were of the size of 200 terabytes, which we were churning. So churning that kind of data, even as simple as, you know, as simple as cleaning up the data into three column rather than the full use request would require enormous amount of effort, enormous amount of time if we are using some other system. So that's why MapReduce was very successful in this case. Okay. So this was the real world scenario. I mean, why I call a real world? Because I have worked on it. Okay. But there are many real world case scenarios where Hadoop is used. So Hadoop could be used for simply, okay, so Hadoop could be used for very simple tasks such as you have a lot of unstructured data lying around in the organization. Some are in video, some are on PDF, some of that is plain text, and you want a common central storage to put it. So that's a basic use case of HDFS, and there is probably no alternative to HDFS as of today, because HDF is like proper file system, and having data in the file system is the easiest way to interact with the data, right? Easiest as in every tool understands it, every user understands it. If there is a database somewhere, then you have to have this query language to access this data, and then you might have to have API to access the data. You might need developers or DBAs to access the data. Therefore, the file system is probably the easiest and most user-friendly way to store the data. So HDFS is anyway used in almost every real-world scenarios where we are expecting a lot of data. Okay, so I hope I was able to answer Webhub. All right, great, great. So should we start with our discussion? Now we have, I think, other people also in the session. All right, so actually, there were few queries from WebHub before before others were joining, so I was answering them. All right, great. So let's start our discussion. Do you have any questions before we start? All right. So I think we were discussing this particular problem. right? So the easiest way to do it is the key selection should be either pick up the actual word or pick up the mirror of that word, all right, based on some criteria such that mirror as well as the normal one should get, I mean, in either case, there should be the same key, all right? So the recording has been started, yes. So the way we are doing key selection in this, so again, the problem statement is bring all the users together who have either identical DNA or reverse DNA, completely reverse opposite DNA. So ACGT and TGCA both are opposite of each other. Okay, so user 1 and user 4 belong to the same family because they have identical DNA, and user 1 and user 2 belong to the same family because they have exactly opposite or exactly reverse DNA. Okay, now how do we form the key such that MapReduce automatically would bring user 1, user 2 and user 4 together? Okay, how would you do form the key such that user 1, user 2 and user 4 will have exactly same key? If we try to say do the similar thing as we did in case of anagram, in that case user 6 and user 7 will also become the part of the same group, right? And user 6, user 7 and user 1, user 2 and user 4 all will become part of the same group, which is not something we desire, right? Now, okay, I'm so sorry. Okay, Leonid says that create two copies of each record, one with the standard DNA and one with the reverse. That is okay, good approach. But then at the end of it, if you think about it, doing the deduplication, as in removal of one of the duplicate, will become almost impossible task. Still, the two things will be completely separate. So if you do the mirror, user 1 and user 4 will come together, okay? And they will come together, but doing the deduplication will be a very mammoth task. All right, if you can suggest me a way to deduplicate, that will be great. Okay, or let me ask you this way, same question, that if we have I'll just do a little bit of, so if we have a list of words, remove the mirror image, remove the remove the one of the mirror one of the mirror image, I mean mirror or reverse of the word. Okay, so you only have to keep uh, you only have to keep a word or its mirror. Again, you will end up with the same problem. Only keep either the word or its reverse. Yes. Okay. So the approach we are taking here is similar to what Matthew has taken. And yeah, so Matthew, stay informed that at a point of time in your map function, only one row will be available. The whole data will not be available. So at the same time, you cannot compare one with the another. Okay, keep that in mind. If that is you are hinting at. So you are saying I had said use in the statement like okay like this. If the statement in the logic and if variable equal to ACGT or variable equals to TGCA, add to the key. Now the problem with this is that we don't have access to both of these at the same time, right? All right. Now the only way there are few more ways to solve this, and one of those ways is take a DNA, take a DNA, reverse it, and then pick the smaller one out of the two. Okay. So this way, in case of a mirror image as well as this one, we will always get the same result. Okay, so let's take ACGT and the reverse of ACGT is TGCA and the minimum of the two is ACGT. Okay, similarly in case of TGCA, the mirror image is ACGT and the minimum of the two is ACGT. When I say minimum, minimum means if you place them in a dictionary, normally or Oxford dictionary, which one will come first? Okay, so the one which is starting with the A will come first. Okay, same could have been true. Same could have been true if we put max instead of min, as in TGCA. Then in this case it will be TGCA. In this case it will be TGCA, right? So what we are trying to do, we are trying to make the keys for user 1 and user 2 and user 4 identical so that MapReduce will automatically bring them together. Meaning we are breaking down a problem into a sorting problem so that if we have this list and we can quickly sort, then we'll be able to bring these users together. Otherwise, in a normal case scenarios, we'll pick the user one, we maintain a hash table, or we'll search for this and keep on comparing with all of the words, which will be a very humongous task. If you pick this one, compare with the second one, the third one, then fourth one, and so on, then it'll be a very very slow process and very huge task. We'll not be able to divide it across the multiple computers, right? So is this approach clear to you? Now once we have formed such a key, then rest of the things will be done by MapReduce and will be easier. Okay, any questions on this? Is it clear to everyone? Yeah, Anandita, Deepak, Kiran, Matthew, Leonid, and Vaibhav. Okay. So we are not looking for TGCA beforehand, above. I'll show you this. Okay, so let's say we just in our map task. So our map task, again, I'll try to write some. Let's say this is my code. Define map. Okay, and we are given the line in the input. Okay, what we are going to do is we're going to say user comma DNA equals line dot split. So we got user and DNA, and let's say there is a reverse DNA equals to, we do the reverse as in string reverse. Okay, DNA dot reverse. Okay, this will basically do a string reverse. String reverse as in character by character, the whole string will be reversed. Okay, and then I'm saying if reverse DNA, not DNS, it will be DNA. Okay, if reverse DNA is lesser than DNA, then return reverse DNA, else return DNA. All right. So now is it clear to you? So basically, one line will be given to my map function at a time. This one. So I'm not searching for anything else. I'm just forming the key based on, or here I'll have to do emit, reverse DNA will be my key, and my actual word will be, actual user will be in the, this is my key value, emit DNA and the user. All right, now Matthew says if I don't see how user2 will be sorted into the group. Okay, that's basically the same because it uses an if statement. All right, so here what am I doing is I'm not really going through the whole list. Okay, because in my map function, I will not be made available all of the data. I will be only made available this particular data. That is that is how the map reduce works. So in case of this one, I will be made available only one line at a time, and I have to emit the key such that it solves my problem. Okay, because it could have been very easier if all of this data was available to me in the memory, and I had the luxury of picking one and then searching ahead, comparing whether user 2's DNA is either same or reverse and so on. That could have taken around n square, if there were n number of records in total, around n square cycles to solve my problem, right? The which is humongously slow. Now here I'm basically going through it and forming it like key value pair which can be sorted by Hadoop, such, and after sorting all the users which are coming together, all the values which are coming together will belong to the same key, and hence it solves my problem. Did you get the difference? I think maybe Matthew, you were doing the same thing, but yeah. Does it make sense, Matthew? Were you trying to do the same thing? Oh, okay. Okay. So you were not comparing each string, you're just sorting them. Okay. Okay, good. All right. All right. Okay. Okay, great. Great. Now, Leonid is saying that how would how would map do the sorting if one line is passed into it? Mm, yeah, yeah, we cannot do the sorting. We don't do the sorting. Okay, we cannot here because map function cannot do the sorting. We will just emit these. Hadoop will gather them, and then Hadoop will do the sorting internally for us. Okay. Okay. So how does this thing work? The way most of the string comparison work is you can have a look at this. So I'll show you. So we can say Sandeep is less than Weber, for example. So you can see it's true. Yeah. And the way it does is it starts from the left character and moves to the right, comparing with each of the characters correspondingly on the other one. E- Whichever string finishes first is smaller than the other string which is not finishing first. Second, if any of the characters, say first S is smaller than Vaibhav, then this one is smaller than this string. Okay, just like in the dictionary, if you have to arrange the names of people in ascending order, Leonid, that is very correct. All right, that is very correct. So his point is, so Hadoop is basically doing the sorting and map is preparing the data and reduce is filtering or grouping the data. All right. Yes. Great. Great. Any questions on this particular one? No questions? Anindita, did you get your answer? Okay. Vaibhav? All right. So Matthew is saying on the quiz, do we need to write the code or pseudocode? Either one will do. Okay. Either one will do, code or pseudocode. But it becomes very easier to for me to evaluate if you are doing the actual code. Because in case of a pseudocode, I mean, sometimes we do not detail it. We just say that prepare the key which is similar. Okay. So you could also write things like prepare a key which is same for cases, all such cases, and then you will say emit that key and value. Okay. Now this is also pseudocode. So this kind of pseudocode will not be accepted. You'll have to do the detailing. Okay. All right. Now, next problem is a little bit more difficult. This problem is of a very high significance because probably this kind of problem was the one why this whole MapReduce was invented in the first place. And we'll talk about it in a minute, who and why. So let me describe the problem. In this unusual democracy, everyone is not equal. The vote count is the function of worth of the total voters. Worth of each the vote count is the summation of the worths of all the voters. So who all voted for a person, we find out their worth and then sum it up, and that becomes my vote count. So if rich persons are voting me, then I will win. Okay, more rich persons are voting for me, then I'll have more vote count as opposed to another person who has got equal number of vote, but he he has got votes from poor person. So so it's this strange democracy. And okay, so let's take an example. A, who is having a worth of 5, and B, who is having a worth of 1. So A and B are voting for C. So the vote count of C would be 5 plus 1, that is 6. There's a vote. There's a worth of A and B. Now the problem statement is you are given two lists, two different files. One file containing one file containing who voted for who. Second file containing second file containing the worth of each person. Okay, the second file contains the worth of each person. Now your job is to find out the vote counts of everyone. Okay, so lots of people are voting for lots of people, and we are given the worth of people, almost everyone. And you have to find out the vote count. Okay, there could be a scenario that somebody voted for you and he doesn't have a listing in the worth. Or there could be another scenario that nobody has voted for you. Okay, so be aware with that. And in that case, in case nobody votes you, you should display a vote count of 0 against the name. Okay, say nobody has voted for A, so A's vote count is 0. Okay. Yes, person is same as voter. Yes. So votee and voter are all persons. Okay. Those who voted and those who got, both are persons. All right. So even if somebody has not voted for somebody, let's say there is this person called F who is not a votee. So the F's worth will also be made available to you. In this example, it's not displayed, but in the real one, let's say F's worth will be displayed to us, let's say 8. Okay. Kiran's question is, do we have to process file by file? Will map function take 2 lines from the each file? So Kiran, the way it works is when we are launching our MapReduce, we can provide it a full folder or a list of files as input. All right. So, so when you provide the full folder, it acts as if the two files, all the files have been concatenated. So the records from file 1 and records from file 2 will be appended. So records of file 2 will be appended at the end of the file 1. Okay, will become like a single file. Okay, good question. Okay, so Leonid says the create a map function to do left outer join, that is the set operation. Okay, and how would you do that? And please remember, the problem statement could have been far easier if we could just load list 2 into the memory. Okay, if you could just load list 2 into the memory and we run our map on list 1, that could have been really easy. Okay, we could have just said that load the second table into the memory, and in the map that would be made available by something called distributed cache. The way our script was made available to our program, when we said minus files, in the same way we could make the second file available into the cache. But again, if the file is really huge, we cannot load list 2, or we cannot even think of copying list 2 into the distributed cache of all the machines. Okay, again, distributed cache is something, a mechanism provided by Hadoop, via which we copy the smaller data onto all the machines before our MapReduce job starts. Okay, so if list 2 had been smaller, or list 1 would have been smaller, we could have done this, we could have loaded either of them into the memory, and then we could just run through it and print it. But that's not the case right now. So any suggestions? All right. Now, Kiran's question is, how can we identify two files where each file has its own format? Right now, you can assume that these votee and voters are separated by only tab. So it will look like inside the file, it will look like this. Okay? Like inside the file, it will look like this. Yeah. So let me just show the web attempt. Okay, here it is. So Vaibhav is suggesting that inside our mapper, if we could just do voter and votee and split the line, good. We got voter and votee, and search in voting table for voter. Okay, so basically, this should have been like, we could have been lucky if we could do this. This search operation would happen. This search operation, this one, is going to hit you really hard, because first, the other data which you are trying to load in SQL is also huge. Second, if you are looking for each one, say you have each line and you are trying to look into the SQL, so for every line you are hitting the database. So there's an overhead of searching, and then there is an overhead of network. Makes sense, right? Kiran's question is, okay, So Kiran's question is, how can we write a code in map which needs to be applied uniquely for each file? No, we cannot. We cannot. The only thing we could do is, uh, Kiran, that let's say there is a list 1 and list 2. Okay, so we could run map such that they become in a format, let's say my TSV. Okay, so make it a tab separated format in both the cases. Okay, and yeah, so both become in this, we bring both of them in the same format. Okay, and then for the next map we'll say my dash tsv1 comma my tsv2, and we'll send it to the signal. Make sense to you now? Is that what you are asking for, Kiran? All right. So it's a two-step process. If your two files are in completely different format, then you cannot right away use things in that manner. Again, continuing with Kiran's question. Yes, you might have to. Also, in this particular problem, please be aware that we are going to use multiple phases of MapReduce. And multiple phases of MapReduce is like saying, first MapReduce will load the data from HDFS and save its output into HDFS. Again, second MapReduce will pick the data from uh, HDFS and put it back. So running MapReduces in a chain is not a big deal. It's like running two separate processes. All right. Going back to the other questions. So, Kiran, was I able to answer your doubt, clarify your doubt? Okay. Now, all right. Okay. So Matthew says the keys are in list 2 and values are in list 1. You can think of it that way. Okay. List 1 and list 2 have to be sorted first. Okay. Okay. And then map function to find matches will not require going through a lot of rows. Okay, interesting, interesting. Though it's a correct approach, but we need to think about how can we do a similar thing using MapReduce. All right. Okay, so WebHub's mapper looks like this. Okay, so here the problem with this, okay, when I said things like this, it does not mean that these two files will come, one along the side of second one. It will be actually equal to concatenate this and this. Okay, so if your if first file, let's say this file this file contains say x, y, and z, and the other file contains a, b, and c. So this would basically mean we have x, y, z, a, b, c. This is what it looks like. Okay, make sense, Vaibhav? Because here you're assuming that these two lines are being joined automatically, right? That when we are concatenating, uh, when we are putting these two files, this one and this one, as the input, okay, then it will automatically come together. But you are on the right direction. Keep going. All right, let's pick Matthew's suggestion. The keys of list 2 can be set to numeric worth, okay? And then list 1 can be sorted into how many of each gets a vote equal to 1, okay? The keys of list 2 can be set to its numeric worth, okay? And then list 1 can be sorted into how many of each gets a vote equal to 1, okay? And then get the vote count. The key can be multiplied to get number of points in vote count. Mhm, mhm. Okay. Maybe I need to understand it a little bit more. Yes, Vaibhav, it will append to the end. All right. So what if we could concatenate list 1 and list 2 such that the worth of the voter and the people who a person has voted to, this and this will all come together. So C, B, and 5 will come together. And then in the second phase we could do other things. Okay, let's take a look at it. Imagine this. We have list 1 and list 2. Okay, so in the first, what we did was we just fed both list 1 and list 2 to our mapper. Okay, and making the first column as the key. This one is the key, this one is the key. So basically after Hadoop sorts it and groups it, it will look like this. For A, C5 and B, C5 and B will come together. C5 and B will come together. Okay. For B, for B, C and 1 will come together. Okay. And for C, 11 and F will come together. And for D, there is nothing on this side, so it will be only one element. Okay. And for F, there is only one element. So here there is a little bit difference from the problem we discussed. Here actually D. All right. And here we have one more, C and F and F and C. Okay. So we have also F and C here. So in this case, what's happening is we are just concatenating list 2 and list 1, and it's behaving like it's a single file. And after that, we are just making the first column as the key. And therefore, all of the values are getting together for that column. And now in reduce phase, now reduce phase is doing something good. Generally, what we did was, in case of reduce phase, we just summed it up, did some average, or do something else. But here, what we are doing, we are unfurling it. We are unfolding it, as in here, this statement means, if you look at it closely, it means A voted to B and C, and A's worth is 5. So we could say that because of this particular voting instance, because of this voting instance, B will get 5 votes, C will get 5 votes. Similarly, because of this instance, because of B voting to C, C will get 1, and F will get 11, D will get 12, and here C will get nothing because F does not have any vote. No, D will not be able to, I mean, nobody gets anything because of D's value, because D has not voted for anybody. Okay, therefore, we prepare this list. The output of reduce is B5, C5, C1, and F11. See, because of this, we got these two. Okay, because of this, we got this one. Because of this, we got this one. Okay, now the role of Hadoop is very simple. Make the first one as the key, and bring all the values of B. B might have been voted by somebody else as well, other than A, and C might have been voted by somebody else, like here C is voted by A, here C is voted by B. Okay, therefore, now when you unfold it, all the people who have voted for it, all the values which these keys are getting, they get summed up in the second page. Does it make sense to you? Yes, that's correct, Vaibhav. So, yes, you are right. So, there is a minor correction, all right? There's a minor correction, thanks to Vaibhav. Okay, will not be able to report A0, any person who did not get any vote. So, can we do something about it? All right? Anybody has any suggestions? All right. We have another good point from Kiran. Let me take that one. Okay. So I can clean this, right? I think I can clean this. Just clean this. Okay. Very good. Yes. Okay. Leonid says that go over it from the beginning. Cool. Let me go over it from the beginning. All right. Or so we have got list 1 and list 2. Okay. Now we have just concatenated these two lists. Okay, we have just concatenated these two lists, as in to our mapper, I'll just clean it. Yeah. So let's imagine this one. All right. This is how it looks like. So, okay. So this is our list 1. And feed, when we feed this list along with the other list, this is how it would look to, this is how it looked to our, this is how it looked to our mapper, that it has got two lists in a single shot. Okay, this big file, that's how it looked to our mapper function, that this big file has come in for processing. Okay, now Here we are considering everything as a string right now. Okay, we are considering everything as a string, and in the mapper, okay, now when we get the result in case of our mapper, what we will get is we'll get it sorted, right? And these things will get together, as in this will get together with this one, and this will get together with this one. Okay, like this and like this. Now you see that? So we sorted it and it will come together, and that's the role of Hadoop. And this is what you will get per one record at a time in your reducer. So your reduce function will be called on this row, this row, this row, and this row, and this row. Okay, one at a time. So total number of calls for your reduce function will be 5. Okay, now the next step is that our reduce function will convert this. So we will convert each of them. Let's say this will get converted into into something like b space 5. Now question is, sorry. Now question is here, the problem is that how would you identify that something is a value and something is a name? So here we are just using a hack, as in if something is starting with a digit, we call it the worth. And if something is not starting with a digit, we call it the user. Okay. So out of this array, we identify which one is the worth and how much is it, and we award that worth to all the users, and we print this out in this fashion. Okay, and we can also taking in consideration the webhub's point, we could also say things like a0. Okay, the the situation, because we want to report that a got nothing because of this transaction, we could do things like this. All right, and in this case, can somebody tell me what will be the output here? It will be c and 1. Here, when the reduce function runs on it, we will get the result as f11. And since it's not voting for anyone, and here also c0, okay, again c0, and in this case we could just say d0. All right, again here also we could say c0, f0. All right. Now, this is just error handling. I'm just placing 00 everywhere if somebody is not voted on. Okay. Now, at this point, let me just collect all of this, just like Hadoop will do. And let me just gather all of this, whatever we have generated just now. All right. Okay. So now we could just say sort, and then we could sum up all the values for the keys. Okay. So this will be 0, and this will be again 6. Okay, this will be 11, not 11, no, this will be 0 only, because the last one, oh no, I think this was correct. Okay, all right, so now you can see that we have got what we wanted. 5, 6, 11, that's what it is. So I hope you got my answer. So Vaibhav, was he able to answer your point? Your point was this one that we have solved by putting 0 to the person who is rewarding also. So here reduce function logic should identify the voting by data type like numeric. That's correct, Kiran. Yeah, that was a very good point. Now, all right, all right. I hope that I'm able to answer your questions. Yes, that's correct, Matthew. If the voter has no votes, then no numeric value will be in the array. Yeah, so it'll be 0. Great. Kiran, did it make sense to you? Leonard? Yeah. So was okay. Anandita, Deepak. Okay, okay. So Vaibhav's question is that both list 1 and list 2 will be loaded in HDFS, correct? Will be in the HDFS, okay? And let me just copy. Yeah, that's easier to do. So both list 1 and list 2 are loaded in HDFS, which means every data node will have a block from list 1 and list 2, and our mappers will work on each block. Okay, and our mappers will work on each block. Mm, okay, not really. So a data node will there is no guarantee that each block from list 1 and list 2 will be there in in the in the each of the blocks. The way it's happening is some translation is happening on file 1, all the blocks of file 1, some translation happening on file 2. Okay, parallel, I mean this is happening via running the map function, and in the shuffling phase, that is before the reduce phase, in the shuffling phase the data is being brought together. The data is being brought together because of the shuffling phase, not because of blocks being nearby. Okay, all right. Leonid says that mostly he has understood, but will need to review the recording once again. Okay. Yeah, you can try it right away, as in as soon as the session starts. Kiran's point is that when we get chance to try it in practically to the in the lab, you can try it right away. You can basically write it in basic. I mean, create two files, file 1 and file 2. Put it in your HDFS and feed it to your pipe. I mean, shell program or whatever program you want through the Hadoop streaming. Okay. So Web's question is we will need multiple reducers, at which point aggregation will work. Yes. Okay. So Kiran, you should try it right away, as in as soon as the class finishes. And the way we had done our rest of the job, as in the way we had run our simple word count, in the same fashion you can write your mapper reducer using either the shell or Python or whatever you want. All right. Okay. So even if you are using Java, then also since you can run Java program like a normal command line program, you can do that. But if you want, you can have a you know have a look at the session number 4 or 5. There is Java project. If you look at the Java project, you'll be able to figure out quickly. Okay. Anyway, I'm going to cover it. All right. So, Weber, your question was, we will need multiple reducers. That is correct. At which point will aggregation work? So, here, when the shuffling is here. When Hadoop has got the key value pairs from you, and then Hadoop will do the shuffling, and aggregation will happen here. And the reduce will convert the aggregated values into one together. All right, that is good. All right. So was I able to answer your question, Vaibhav? Great. All right. Now, after looking at these four problems, and you will see other problems as well, you'll get a feeling that every problem in the world can be solved in using MapReduce. But there are limitations to use MapReduce. Okay, but be aware that anything that could be done with SQL can be done with MapReduce. So we demonstrated in the problem number 4, the last problem, that this is how you can join the two tables. Before that, we demonstrated how you could do the job of group by, and of course order by is straightforward. So most of the things that could be done using SQL can be done using MapReduce. But not true vice versa. Like for example, anagrams problem, it's actually quite difficult to do it using SQL. Reason being, reverse string kind of function is not readily available in most of the SQLs. Therefore, lot of problems cannot be solved using SQL, which can be solved using MapReduce. The main reason being, MapReduce are full-fledged programs. They are full-fledged programs, and therefore, I mean, programs can do the more kinds of work as opposed to the SQL. All right, but there are limitations to MapReduce. Okay, there are limitations to MapReduce. The way we avoid doing looping in case of SQL, right? We avoid writing the loops and sequential processing in SQL. Similarly, in case of MapReduce also, we have these problems. Okay, so why I keep comparing MapReduce and SQL all the time? Because both are paradigms of computing. Okay, all right. Now, question is, then what are the limitations of MapReduce? First and foremost, probably this is something which you all need to understand. If you can do it in reasonable amount of time on a single machine, do it on the single machine. Unless you are expecting some data in future, maybe few years down the line. If you're expecting some data which will be beyond the computation of a single machine, then unless that is the scenario, okay, you always run it on a single machine. If you can do it on a single machine, do it on the single machine. Otherwise, otherwise, if you can't do it in a reasonable amount of time in on a single machine, then you go for MapReduce. Now, second reason is that if your computation depends on previously computed step, such as Fibonacci series. How many of you know what is Fibonacci series? Yeah. So a Fibonacci series is, anyone? In Fibonacci series, we compute the next term by the summation of previous two terms. So the third term will be summation of first two term, and fourth term will be the summation of second and third, and fifth term will be summation of fourth and third, and so on. So that's how it works. Now if you have to compute a billion Fibonacci entries, as in you have to find out first 1 billion Fibonacci series entries, and you thought that you could distribute it on multiple nodes using MapReduce. You cannot. Reason being, reason being, to generate the third one, you need the first two, and so on. Effectively, the next step cannot progress unless the first finishes. Therefore, one machine cannot start the work while other machine is running. Next node can only work if the previous one has finished. Therefore, there is no benefit of running Fibonacci series or computing Fibonacci series using multiple computers. So problems like Fibonacci series are not possible to distribute. Third is real-time response. Okay. So if you are expecting the real-time response, as in as soon as you feed in the data, you get the result, the MapReduce will not solve your problem, because MapReduce is designed as if it's a batch-wise system. Therefore, it doesn't make sense to use MapReduce in case of real-time system. Now, fourth problem, which is difficult, if your each of the step depends on a global state. Every time you have to run a map, if you have to call a central global state, okay, if you have to call central global state, then it'll be very, very slow. Yes. Okay, yeah. So those who are still wondering what is a Fibonacci series, thanks to Leonid and Webber, this is how a Fibonacci series generally looks like. Okay. So 2 is equal to 1 plus 1. The next term is 3, which is 2 plus 1. And 5 is summation of these two. And 8 is summation of 3 and 5. All right, you can see that. So it actually starts increasing faster as the terms grow bigger. All right. Now, in case your algorithm is depending on the shared global state, do not use MapReduce. All right. As a thumb rule, how to test MapReduce? We just showed you a simple example of running word count, and the general thumb rule for testing is first test on small data. Okay. So, I mean, first test on a small data, then you test on a sampled small data. Okay. Reason being that unless you do the sampling of the data, you will not be able to test it thoroughly. Next is separately test mapper and reducer. Always test separately. First, check whether your mapper is working fine. Then you check whether the reducer is working fine. You have an expected value in all the cases. This is my standard input and this is my expected value. Is it comparing with the real value? So that's a kind of test we do for mapper and reducer independently. And once you have got both mapper and reducer running fine, you could test mapper and reducer in conjunction with each other by using a command like this. That is probably the most beautiful thing about this Hadoop streaming. The testing a Hadoop streaming job is very simple. For example, look at this one. I'm saying if you have written my mapper and my reducer, I could just combine them into this sequence and we'll get the result. So cat input file, pipe it to my mapper, then sort it, then send it to my reducer, and we'll get the results. Okay. Next is use MR unit. Okay. In case you are not using a streaming job, you're using Java, then you can use MR unit. We'll talk about MR unit when we talk about Java. Fifth is that we could test the predictions. We could to test, because in lot of cases whenever we are using MapReduce, we will be doing predictions. We will be doing predictions as in using tools like Mahat, we will be generating predictions. And now you will wonder that whether Mahat is doing good or it's doing bad. And in all these scenarios, to test any of the predictions, we we do something like splitting the data set. Okay, for first half we do the predictions and then we compare the results of the prediction against the second half, meaning that our algorithm is saying based on the first half that Webhub will buy an Xbox. Okay, we are preparing recommendation, and then our algorithm is saying based on the first half of data that Webhub will buy Xbox. Then we'll compare in the second half that did Webhub really buy Xbox? If really bought the Xbox, that means our confidence level on algorithm is really good. Okay. So generally we split the split the input data into two parts. One we call it learning data set, other is called as test data set. So that is one important point to remember in case of testing the prediction analytics, testing the predictions of anything. It's like if somebody comes to you and says that I can tell you the future, you ask him, can you tell me the past? Okay, and that's how most of the recommendation testing happens. All right. Okay, so there is one more problem which we would like to discuss, and that problem is you should first is you should code these four problems in your own favorite language other than doing it in pseudocode. You could do it in your own favorite language. Also, create a project on GitHub with your code. Mention no bigdata.com in the README. Okay. This will be quite useful. And why I'm insisting on putting it on GitHub, it will give your profile a public visibility. Also, you will get to learn the newer source code management systems such as Git. Okay. So I would strongly recommend Git because almost everybody has moved to Git, including companies like Amazon, Google, and Firefox, Linux, of course. So the biggest code bases have already moved to Git, and that is why I recommend that you should know a little bit of Git. All right. All right. Now there is this problem number, you can say 6 or 2, whatever. Assignment for session number 2, session number 3. Based on the content from a very large archive, formulate the next word's recommendation. You must have seen when you use a mobile phone and you're typing a word like happy, it instantaneously gives you the 5 next recommendation, such as birthday, new year, and marriage. Okay, so because it has already prepared a list of these recommendations which can really work, which can give you a quick suggestion on what to type next. Okay, and this is quite useful to the mobile users. And how do you generally generate it? So the strategy here is we will go through a huge amount of text. You can actually download it from Wikipedia. Okay, or you can just try your program on a smaller data first. Now, given this whole text, what will you prepare? You will prepare some sort of key value pair such that all the words that follow a particular words come together and you pick the top 5 of them. You do the frequency computation for the values for each word, the the successor of each word. You do the frequency computation and then say that these are the top 5 words. Okay, so think about the problem and try to solve it. It is going to be very, very useful to you. All right. Is the problem statement clear to everyone? Yeah, Vaibhav, Anandita, uh, okay, Deepak, Kiran, Leonid, Matthew, Vaibhav. No. So Kiran's question is, thank you, Kiran, again for this. We are not expecting a real-time response. Okay. Reason being the way these systems are designed, that once you prepare these recommendations, you will store it on a server on in a small database maybe, or maybe in some other database. You will just save these recommendation on your web server, and from there that can be catered by multiple means to the end user. Okay, so whenever user is typing on their mobile, they will be hitting some web service, and that web service will read our data generated by the recommendations. All right, Webhub, is that does that make sense to you? All right, all right. So think about this problem, and let's move on to the next session. Okay. So these recommendations are saved in arrays. That is the question from Matthew. Not really. We generally save. So when we have the strategy is, I mean, in general, the way I have done this kind of work is prepare the recommendations and store it in a database such as Redis. Redis is an in-memory database where you can store it like a big object, key and the values, and the values might be an array, and the whole thing will act like a big hash map, and it will be in a hash map form in the Redis kind of database, in the in-memory database, so that when the user is requesting for something, the response is blazingly fast. Okay, sort of you can say yes, sort of you can say that it's a JSON kind of a format. All right, good, sounds good to you. But I would not be expecting like JSON kind of format. I'll just expect a flat key value pairs. Okay, value be separated by comma, that's all. All right, good, good. Let's move on to the session number 4. So that was our attempt to solve the the tough problem using MapReduce. Okay, So the actual assignment have to be done by you. I can only help you a little bit with respect to the concept and with respect to the idea. All right. So okay, yeah, we'll discuss this problem later. Let's start with couple of questions. All right. Now here are the few questions for you. All of you need to interact and answer the questions as we discuss now quickly. Is everybody with me? So the data generated by mapper is given to reducer and then it is sorted or shuffled. Yes or no? Okay, Vaibhav says no, Matthew says no, Deepak says no, Kiran, okay. Great, great. All of you got it. I'm very happy. All, everybody has got it right. No, the output of the mapper is first shuffled, sorted, or shuffled slash sorted, and then reducers are called. Good, good. Everybody got it right. Now, next question is the mapper can only generate a single key value pair from an input value. So, if you remember our problem where we were giving line as the input to our mapper, can mapper generate as many keys as it want to, or it has to only generate one key? So, mapper can only generate one key. Is that true or false? So how many keys did we generate for each line in case of word count? Deepak and Vaibhav? For each line in case of our word count, how many keys did we generate? We splitted the line by space, then we iterated over this array, and then we created the keys. All right. So when we get an input data, if you have that thing running, all right. So let me explain to you. So mapper can generate as many key value pairs as it wants. Okay? It is not restricted to only generating one key value pair. In our example of word count, the mapper function received a full line as the input and it generated many key value pairs for a single line. Okay? Correct. Based on the logic, it can generate multiple key values. That's correct, Vaibhav. All right. So Matthew and Deepak, are you convinced? All right. Now, now here is a little sort of the variation of the previous question. A mapper always have to generate at least one key value pair. Here the keyword is always and keyword is at least. So, so do you think a mapper is bound to give at least one key value pair, or can mapper choose to stay at its own? I mean, sorry. So can mapper generate no key at all? Can mapper try to can mapper skip uh, generating any key, or is mapper forced to give at least one key? Correct or wrong? No. Mapper is not bound to give any output. Okay, it is up to mapper whether it want to give one key value pair or no key value pair or multiple key value pairs. Okay, all right. So the answer is wrong. Is everybody convinced? You have any questions on this? So Matthew is saying, how can anything be sorted without keys? So here, what am I saying is that if we don't want to generate a key value pair, we can do. Mapper is not supposed to generate key value pair all the time. It can skip. You can say, okay, I did not get anything in this line. The whole line is filled with special characters, and I don't want to generate any key value. Okay. While doing the word count, you realize that there is a line which is empty, and you can choose not to generate any key value pair for that. No. So yes, you are correct, Deepak. If key value pairs will be skipped, then the data won't be processed. Yes. So since our mapper function is going to be called thousands of times for each of the line of the text, for some lines it may choose not to generate any key value pair at all. Now it makes sense, Matthew? Alright. So mapper can choose not to generate any key value pair for some inputs. For some inputs it should generate. Alright. Now next question is, by default, there is only one reducer in case of streaming job. Is that correct, or is that yes or no? All right. So let's answer this question after the break. Okay. Hi, I'm back. Should we start now? All right. All right. I'm assuming all of you are back. Okay. So by default, there is only one reducer in case of a streaming job. What do you say? Is it yes or no? Yeah. So I think everybody has said yes for this. Yes. So yes. By default, in case of streaming options or Java, I think there is. In case of Java, the number of reducers are decided dynamically, and we will discuss about Pig later, where the reducers are decided dynamically. But by default, there is a single reducer in case of streaming job. But you can increase, but it can be increased by mentioning this configuration option, as we have showed you. Putting -d mapred reduce task equals to 2 created two separate files in the word count example. All right. Okay, so again, a little bit of a quick refresher. What is the role of job tracker, A or B? A is executing the MapReduce logic, and B is delegating the MapReduce logic to task tracker. Job tracker, when you have job tracker, does it execute the MapReduce logic or delegate the MapReduce logic to be executed to the task tracker? And remember that task trackers are located near the data, near the data nodes. So MapReduce logic, as per the B point, should be executed on the task tracker. All right. Correct. Correct. Great. Great. Almost everybody's correct. Now, next question to all of you is, the map logic is executed preferably on the nodes that have the required data. If you are processing some data using some logic, that logic should be performed as close to the data as possible. True or false? I mean, yes or no? Correct, correct. That is correct. So, this is called data locality optimization. We will discuss it in detail. We'll discuss it in detail afterwards. Yes. So, yeah, that Leonid's question is, why does it say preferably? Because of this question. So the map logic is always executed on the nodes that have required data. Correct or wrong? Webber says wrong. Matthew says wrong. Leonid says wrong. Okay, so you got it right. All right, good. It's not always executed on the same node, as Webber says that it should be sometimes near the nodes. So Hadoop will try to execute your code near execute your map function near to the HDFS block as much as possible. But in case that is not possible, it will try to execute it very close by. Now, where does Hadoop store the result of reducer? In HDFS or in local file system? Anyone? The output of our word count was stored in HDFS or local file system. Anyone? Vaibhav says HDFS, Deepak says HDFS, and Leonid Matthew. So if you remember our word count example, after we had finished the job of Hadoop jar, streaming jar, where was the output of the word count saved? Was it in the local file system or was it in the HDFS? Did we check it through the hue as well? Because hue, anything you check through hue is HDFS. All right. So yeah. So it is done in HDFS. Okay. It's not in the local file system because you submit the job and then you forget it. Okay. At the end of it all, it goes to the HDFS because most of these jobs run in the background. So the output should be saved somewhere in a reliable place. Now, where does Hadoop store the intermediate data such as output of map tasks? In HDFS, in local file system, or in the memory? So Vaibhav says in the memory, Leonid says in the HDFS. Anybody else? So intermediate data as in mapper was run on one machine, so there will be some data. Then mapper was would be running on another machine and another machine, and there'll be these different data sets. So these data sets, after will they be pushed directly to HDFS or will they be on the local file system? Okay, so they will be into the memory first and they'll be pushed to the local file system. They will not be saved. They will not be saved in the HDFS. Reason being, the intermediate data is temporary data. It'll be as soon as the data get merged, all of this will get deleted. Therefore, it does not make sense to put such intermediate data in HDFS. Why? Because of the hassles, such as soon as you put the data in HDFS, it will be replicated across the cluster. And in case of temporary data, it's not really required to have such kind of thing. Okay, make sense, Matthew, Kiran, Leonid? So yes, Matthew's point is that I thought that there was too much of data for memory. That is correct. That is why. So the way most of these systems work is on these one end the processes are writing to the memory, and from the other end the data is being parsed into the local file. So that's why for few MB will be retained in memory and they will be continuously being saved into the disk. Why? Because disk has slow speed of writing, but disk can write a lot of data in a single shot. So the only way, I mean, if you see the average write speed of disk is slower, but if you try to write a big size of file in a single shot, then it becomes comparatively faster. I mean, it becomes slightly faster. Therefore, you whenever you are writing to the disk, you keep on writing to the memory, and then it will push it to the disk. All right. The whole of HDFS block. is available on a node that is fed to the mapper. So again, your mapper gets the data from your file, right? For each line, we were executing our map logic in case of word count and in case of all of our problems previously. So if the file is broken down into blocks, this block's data will be given to mapper. Now question is, will the whole block's data be fed into the mapper, or will there be a difference? Deepak says no. Matthew says yes. Okay, there are a few more questions I have not answered. All right, let me answer it after this. Weber says yes, but not sure. Okay, okay. Any other thoughts? Okay, let me rephrase the question. So HDFS block is a hard. I mean, it is cut at a exactly at 128 MB. Whether that cut is in the middle of word or middle of line or, or middle of character. Okay, that if you have multi-byte character, that cut can result in one part of the character on one block, other part of the character on other block. Okay, so if that this partial data would be fed to your mapper, wouldn't it be like passing the corrupted data to the mapper? Okay, just think about it. Let me answer Matthew's question till then. Matthew's question is, I thought it was stored in it is stored in temporary file. That is correct. The previous one, when we were talking about the data is purged into the disk, it is stored in a temporary file, but by the way of what do you call it, a kind of a pipe into the memory pipe. You keep on pushing it to the memory, and from the other side it is being purged to a temporary file, and this is done to speed up the process. Kiran's question is, after map reduce job, after m/p job, will that temp file be deleted? Yes, that temp file will be deleted. All right. All right. So this one current question is a little tricky one. So on one hand, we have been talking about that the data from each block goes to the mapper, each block goes to the mapper. The question is, does exactly whole block is fed, is exactly the whole block fed to the mapper, or is there any boundary, boundary movements, as in, do we try to sanitize, do we try to fix it? Okay, so that is a big question. All right, so the answer is no. The input is split using something called input split. So we read the block, we see if boundary is at the correct place or not. If it is not, then we try to transfer the last line or the first line in order to make it a proper data. Okay, let's think about our word count example. Imagine one of the line is split into two parts. So say block one's boundary is in the middle of line, right? Block one's boundary is in the middle of line, and because if it's in the middle of line, so it might be in the middle of the word or it might be in the middle of character or whatever. So for word count example, this data is invalid. Therefore the last line will be shifted to I mean will be shifted to another node. So block 1 will not be consumed completely. Instead, instead of instead this boundary condition, the line which is being sliced will be transferred to another node. Matthew says if the whole block isn't available, then the data will be incomplete. Data will be complete in the sense that part of the one block is fed to one mapper, part of another block is fed to another mapper. Okay, I'll explain to you more about this today. But before that, I would like to go with a Java kind of Java project so that you can start. Some of you are still wanting to do it in Java, so they can start, and then we'll take up this problem. This is a very important problem what we are addressing just now. Okay, so the idea is that since block is like very raw level division of the data, is a sort of hard boundary, while slicing the blocks, HDFS didn't care whether it's slicing the data in middle of a row, in the middle of the record, in middle of the word, or middle of the character. It did not care. Instead, it just sliced the data, split the data into these blocks. Now, when you are logically processing this data, so the boundaries, the towards the end, the data might look, incomplete. Data might look sort of corrupted. Therefore, the data or the record which is incomplete should be transferred to another node, and we need to process it there. Okay. All right. Now, next point is that MapReduce in Java. Okay. So far we have discussed MapReduce only with respect to the MapReduce in streaming, but why do we need to do in Java? First, the whole component, whole ecosystem of Hadoop has been written in Java, so it's sort of a primary support. Second, you can modify the behavior of almost all of these components using your Java code. You can extend, you can alter, you can do whatever using Java. Therefore, it's very important to know the MapReduce in Java. Although MapReduce in Java is not the only way to do MapReduce, as we have demonstrated that we could do MapReduce using even the scripts, using even any program via MapReduce streaming. Now, so to do this, the first and foremost thing you need to do is install Eclipse. Any Eclipse will do as long as your Java is working on a machine. Okay. So install Eclipse, create a Java project, and once you have created Java project, add all the libraries available there. I have put on my website. I have put a good video. I have a good video on how to configure Eclipse project. Also, I have put couple of more things there in the learning management system. You can see. Okay, so here is the sample project. You can download it and configure it. And here, how to create project. There's a video on how to import the project. You can use that one. All right, this one. All right. Now, okay, so you can import that project. I will. Okay, importing will be far more easier than creating from scratch. Okay, if you are trying to create from the scratch, you can install Eclipse, create new Java project, add all of these libraries available in that folder, and also change the JDK to 7.0. Let me just open Eclipse and show you. All right. So here you can see there is a training too in this. Okay, let me just delete this extra one. All right. In this project, I I have, created a source project and then added all the libraries required. And in the Java build path, I cleaned up all of the old one and put all of the jars available in my folder. Okay. So, okay. Now this is how you get started with Eclipse. Also, I forgot to show you the library. In case your Java library is troubling you, you can go to the last line here and change the JRE to 7 or maybe something else. Okay. Also, whenever you are building any code, not only in Java, but whenever you are building or compiling the code, you should generally keep your version as the lowest possible one. Okay. So for example, I'm trying to compile my code for Java 1.6. Although Java 1.6 is fairly old, still I would like to compile my code for Java 1.6. 1.6. Problem is that when because this Java MapReduce is going to, after getting compiled, you will create jar, then you will ship this jar. This jar will go to your MapReduce cluster, and there it will get executed. Now, in any organization, upgrading a cluster, upgrading servers is a very big task, specifically if it is non-security related. If it is security related, it will systems will get upgraded quickly. But if security is not the concern, then people do not want to break their servers. Reason being, there are lots of other dependencies. Therefore, Therefore, you will find that almost every data center have really old Java version. Therefore, you should always try your best to compile your code for the lowest possible one. Similarly, even if you are writing an Android application or any other application, try to keep the supported version of the phone really low so that you can cater to more number of users. Okay. Th- so that's why I have changed it to 1.6. All right. So you can create a new Java project, add all these libraries, and change the compiler settings to 6 or 7, whatever you like. Okay. Now, after this, once you have created the folder, create a package also. Okay. You can create a package also. Package as in is nothing but you just mention at the top of your file that my file is a part of this particular folder, and you place your file inside that folder. That's all. And this folder is relative to the topmost package. So here I'll just show you this. So here is my mapper. Let me just open mapper. So this is this, you see the node, this is called package. It's like it means folder. I'm keeping my file in this folder. Okay, the way class name is equal to the file name in Java, this package name should be equal to the folder name. See, my, you see, and similarly stubmapper.java and stubmapper. All right. Now inside this stubmapper, what we are doing is we have extended a base class called mapper, and we are telling that we are extending in a manner such that here we are saying that please extend mapper such that our key will be the input key will be an object, input value will be text, output key will be text, output value will be int. Okay, because we are going to say one here. Word 1, word 2, word 1, 1, word 2, 1, and so on, right? So now have a look at this. Then we have to override a method called map. Okay, we have to override a method called map in which we have key and the value and there is a context. We have key and the value and the context. Context is the one which contains lot of information, and you can just go here and say context dot, and you'll see lot of methods inside this, like get configuration, get credentials, get current key, get, there's a lot of methods using which you can find out a lot more about your job. So context is your gateway to interact with Hadoop's MapReduce. Okay, and context is the one to which you will be giving out your key value. The output of your mapper would go into the context. So you can see here that we are splitting the value. This is the value. We are splitting it by tab and spaces. Okay. And for each words, we are here you can see that for each word, we are giving out the word itself. Here, this is basically giving out the word in a wrapper called text, and we are giving out one. Okay. So this is our key. This is our key. This is our key, and this is our value. Okay. And that's how it works. So we iterate over the list of words. For each word, we are giving out key as the word and value as one. And what is more important here is this envelope called text. This envelope called text is required in case of Java, in case of MapReduce. Why? Because MapReduce guys realize that normal text string like this one is not solving the serialization properly. Okay, therefore they provided an envelope called text, in which you have to uh, envelope your string, which is your key, and give it out. Okay, same is case with the number. Instead of using the default Java number, they came up their own envelopes, and those are to be used. All right, so we have splitted the value, and also note that there is a key and there is a value. Okay, which is the input to your mapper. Input to your mapper is key and the value. Okay, and this key and value, the value is line. Okay, each line of the input text, while key is the byte count. It's like line number, but little bit different from line number. It's the character count from the beginning of the file on which character this particular line is starting. So byte count will give you a lot more information about, I mean, it can give you a context like on which line, on how much text has been processed already, and all that. All right. Okay. So is this clear? The map function is clear to you? No? Matthew Webhoff, Leonid. So Matthew, do you mean to say this practical function only works on strings? Okay, okay, okay. So maybe, yeah. So not really. It can have any object here. You will see it later. Okay. It can have any object here. Anything that extends something called, I'll show you. The here, yeah. Anything that is binary comparable. Yeah. So so in case of your own object, you can basically implement something called write comparable, and that would be good enough. All right, no worries. So the way you are writing mapper is in a very concrete terms. You get one key value, you give out some key values, and that's all. Okay. Now the next thing you will do is you will write a reducer. And what does a reducer do? Reducer will take reducer will get a key, and this is list. Okay, it will get a list of values. It'll get a key and a list of values as the input, as the list of values as the input. And over this list we could iterate and then do the summation. Okay, do whatever we want. So we'll be reducing these values into one, or maybe we will be doing something else here. Okay, so this is how the reducer code looks. Again, it also has the same syntax as in public class, stub reducer, extends reducer, and so on. And we are defining the data type with which this reducer need to be extended. And we override the base class, uh, override this reduce method and implement our own, and that's all. All right. Next is once you have created your mapper and once you have created a reducer, in mapper we gave out key values and in reducer we got key and the list of values. And in the driver, what we are going to do is we are going to create first a object of job. This is the object of job. So once we have created a driver, sorry, I'm really sorry. Let me go with the flow. So first we created a mapper. Okay, the mapper that implements map function. Then we created a reducer that implements the reduce function. And then we created something called a driver. Driver is entry point. Okay, driver has the main method, and this is the entry point. And whenever we are going to execute our map reduce process, this is going to be our starting point. And what does driver do? Driver internally creates a job, okay, based on the configuration, and then tell that job that hey, your mapper name is this is the class which is your mapper, and this is the class which is your reducer, and also set various kinds of other parameters such as this is the input folder, this is the output folder. You can see here that we are setting the input folder. Here you can see file input format dot add input path, and this is argument 0. Whatever argument we are going to pass in this function is that is going to be our input folder. um, okay, and this is our output folder. So we basically use job to do everything for us. Okay, here there are these key values which we need to specify. That's something we don't need to explain right now. And once we have set up our job, we have defined the input, output, mapper, reducer, and other criterias, other configurations such as number of reducers. All of that once we have done with job, then we will execute it by this method called job.wait for completion. We'll wait for the job to finish, and then once that finishes, then we exit. Okay, then we successfully exit. So once you have written this kind of code, what you need to do is you export it. You export it to jar. Okay, let me just export it. We call it, let's say, mr test1.jar. It'll be in this folder. I'm exporting it. Okay, and let me upload it there in Hue. I'm doing it because most of you may not have SCP or WinSCP. So in that case, you can use Hue. All right. All right. The file has been successfully uploaded. Now we'll go to the terminal. Where is the terminal? We'll go to Hadoop 3.no big data. Let me try to increase the font. Can we increase the font? Student. I'm using a student. You can start using your own folder. Yeah, is it clear, the screen? Okay, so let me just go into my local folder here. And it's not same as the one which we have downloaded. Let's copy the file. So you have to copy your jar file to the local folder, not from HDFS. So we'll say Hadoop fs minus copy to local asgiri slash mr test dot jar. Okay, we're copying this file from HDFS to local folder. So here there'll be now mr test. We'll say Hadoop jar and mr test dot jar. Now, first command is Hadoop, then jar, then mr test. This is the jar name that contains your whole code. And then the fourth one is your driver. What is the name of the driver? The name of the driver is my dot stub driver. My is the package name, my dot stub driver. Now it says input and output directory. It is giving this error. So it's a good news for us. Why? Because this is the statement that is getting printed. See, you say stub driver and input directory, output directory. So which means we are able to successfully run our program. All we need to do is now provide our input and output folder. And the way we provide input and output folder is asgiri is my relative path from the home directory, and we say word count slash input, and we could also say asgiri word count slash output. Okay, let's see, what do we get? An error? Will it run? So is my what do you see? Do you see my terminal, or do you see the eclipse? Webhub is still seeing the eclipse. All right, I missed a question from Matthew. It says main executes the mapper and reducer. That is correct. The main executes the mapper and reducer. Okay, okay, okay. Now it says that the output folder already exists, so we can delete the output folder. We can delete this folder and say Hadoop fs minus rmr. Okay, so what does it say? It says that it is expecting a value from map. It's expecting long writable but got int writable. Okay, but that's okay. What we can do, we can just remove this, because we had mentioned explicitly that we will be giving int writable, but we have given long writable instead, which is wrong. All right, so I think that is a mistake, because here we have said int writable, and here also we have said int writable, here int writable, and so on. Okay, so let me again have a look at it. All right, all right. Okay, great, great. Let me upload it again. Now in the terminal, let's download. So all of the tasks have failed. It says map tasks have failed, these many. Launched were 4, failed 4. Let me just copy this file. So I'm downloading the file from HDFS to locally. It's a two-step process. Next, I'm copying the. I'm now launching my MapReduce again. Okay, so no, it's only MR test, not test one. Did I give a name somewhere at test one? Okay. Now here the process has started. It's showing the map has that completed this much. Okay. So something has failed again. It's the same problem again. All right. Did I still leave something? Oh, this one has to be long. This has to allow. I'm running it again. All right. So basically, you have to in the program, you while launching the job, you have to tell the input and output formats that you're expecting everywhere. Okay. Again, there is some problem. I'll have to fix it somewhere. Things are not wrong. Correct. Stub reducer is expecting int writable, which is correct. This is giving out long. Okay. All right. All right. All right. Let me just try to do this. Okay. SCP download MR test to Hadoop 3 dot student at Hadoop 3 dot no big data.com under ASCII. Okay, now let's try to see if it can run. So every time we have to delete the output folder, because if it starts processing, it will create the output folder and then it will not work. So this time I was removed all the data definitions. If it doesn't work, then I'll sort it out later. Okay. Okay, so it's saying that received For map task, it received this. Alright, it expects me to do all of this. Okay, so I think we are executing the right one. Yeah. So we are saying output key value is this, and in case of reducer, it's expecting int giving out this. Okay, this is okay. And map output key and map output value. This is correct. This is also correct. All right. All right. This is also correct. Okay, let me delete it in a single shot and copy it again. Oh, I've not exported it. Export it, overwrite it, then copy it again. Alright, now copied. Then we go on to the terminal and try executing. So first I'm deleting the output folder, then running the new one. If you put 2 ampersand on the this Unix cell, it means if the first one finishes, then execute the second one. All right. Okay, so the mapper job is running. Let's see if the reducer will run. Right now it says mapper is 60%, reducer is not yet started. But again, it's the same story in case of it says that Hadoop IO long writable is not class or is not writable. Okay, we need to see why it's not happening. Okay, I need to work on this. We'll get back to this once this get fixed. Okay, I think the one which I have kept in the project that would be working. It's a working model. I just need to see what mistake I'm making in this one. While giving demo, I think I have messed up somewhere. I'll fix it during, yeah, and then let you know. All right. Okay, are you guys with me? Matthew, Vaibhav, Deepak, Leonid, Kiran. All right. So yeah, I think the project which is there in the LMS that should work fine. Okay. Right now I don't have the time to try that out. We will try that out again. Okay. So, but you can try it out. You can just import the project and start running that one. All right. All right. Now that was so this is how you could basically export the jar, then copy the jar to the Hadoop server, then run it using this kind of a command. Okay. And sometimes the other important aspect which I've not mentioned yet, let us say let us say you are writing a you are writing a MapReduce program which need to send email or need to talk to in SQL database, the way WebHub was proposing in one of the problems, that go over this first list, hit the MySQL database. Sometimes that kind of strategies become inevitable. You have to use that kind of strategies sometimes. Okay, so let's say your mapper process starts and then you want to update some database or do something else. In all those scenarios, if you have to do that kind of work, you might have to have more libraries. For example, you might be having a JDBC driver on which your project is dependent, or you might be having, say, Java Mail project, which a package on which your project depend. Now, when you bundle your jar, it goes to multiple machines. That the jars on which your jar depend, the project on which your project depend, may not be available on all the nodes. Therefore, we need to ship these external libraries on which your project is depending by the way of saying minus use dash lib. Okay, that way you can copy all the jars to each node before your MapReduce program is run. Okay, so every time you say use lib, your jar file gets copied onto all the nodes on which your current MapReduce is running. Okay, so the way we were talking about we were talking about MapReduce in streaming, and we were saying that you could put it using minus files. It is the similar option. Okay, so again, there is something called a distributed cache, which is available on Hadoop, all Hadoop nodes. Before a MapReduce process is started, all the files, all the content that is required to be run on all the nodes, we push all the content to the distributed cache, which is available on all the nodes, and then we run Hadoop jar. Okay, makes sense to you? Because MapReduce are these Java MapReduce programs are full-fledged programs similar to any other, say, MapReduce streaming everywhere. Inevitably, in a practical world, you will depend on maybe 10 different other libraries. You will have to ship all those libraries along with your MapReduce program, and that's when you say use lib. So where will you use lib? While executing from here, you will say use lib, like this. Okay, and here you will mention your jar. Let's say my jdbc driver dot jar. Okay, this way this driver will be shipped to all the nodes. All right. Okay, now going ahead. So when you are done with your Java code, you might have to test it. And as you just saw that every time we had to run our MapReduce, we had to go through we had to go through this whole process of uploading, downloading, and running it on the cluster. It was a longer process. Okay. Therefore, it is very important, and more than that, every time we run our MapReduce job, it hits the cluster. Some production job might be running or other people's important work might be happening on the cluster. In case you make a mistake, in your code, there are chances that you will overload the cluster unnecessarily. Okay, so we have a very good question from Kiran. Kiran is saying that if I jar all the important classes into one jar, then we do not need to use lib. Correct, we don't need to. But you will have to use these special tools which are meant for jar merging. Okay, which are meant for jar merging, as in they flatten all the structure of the jar, and then they they merge the folder structure, and then they create a single jar out of it. So you will have to use those kind of components, those kind of tools to combine multiple jars. In though if you have combined it, then you don't need to use lib. Okay, but that's not always possible. But that's a good idea sometimes. All right, good. All right. So if you have a look at this here, there is something called stub test. So you can run a stub test from here. I'll just show you this. Okay, so I have purposefully said that fail here on this one. If you see, I have purposefully said fail here, and then put a test mapper. Okay, again, when you are testing, this is for testing your MapReduce job, because you cannot run every MapReduce job right away on the cluster. You first need to test it. All right, so first you set up the job. Okay, first you create a dummy map driver. You see, here is my dummy map driver. Okay, map driver, and then you have reduce driver, and then you create something called map reduce driver, and then you execute your your driver. You see, here I'm saying map driver dot run. So this is basically a dummy map driver who is executing your mapper and reducer. Okay, instead of using this stub driver, our class, we have created some dummy mapper and driver. If you look at these are basically here, these are MR units, mapper, map driver, and reduce driver, and mapper and reduce drivers. Okay, these are dummy ones. These are emulators. They try to run your mapper or reducer and mapper and reducer together. Okay, so that you can quickly test it in the local environment before pushing it to the production. Okay, these are very good way. This is very good way of testing your MapReduce. It's a full emulation of MapReduce. Okay, so like this is basically a JUnit library which we call MR unit, and in this library we mark each of the functions with a tag. Okay, like this. And in case you want to mark something as a test case, you can mark it as at text. This is a tagging each of the function whether it's a test case or not. And once you're done, you can basically execute it right from here. Okay, so if I just comment out this one, the error will go away. Error will go away, and I can execute it again. All right, see, so we can quickly test it, or say we have say we introduce one more word here. Let's see, does it, what are the things breaking now? Now this one is broken. It says that the size is no longer 11. It is expected 11, but it is output is 12, correct? So so it immediately gives us a feedback. It is running. So we are comparing how many key values are being outputted. We are also we can also do the counting. We can also compare the expected versus actual. All right, that's how we do it using um, MapReduce units. All right. So have a look at this code, try to run it. Okay. Most likely the one which is there in the project will run as is without any hassles at all. Okay. It's just that while demoing, I have actually made some mistakes which I'm not able to figure it out right away. All right. All right. Now going back to the input split philosophy. Okay. And also before this, okay. Yeah. So the relationship between input split and HDFS block. We talked about two things. HDFS creates HDFS blocks, and our MapReduce job, whenever we run the MapReduce job, we process the data and we create input split out of HDFS blocks. Okay? Now, the relationship between an HDFS block and input split is very, very strong because input split is created from HDFS block. The only thing we need to understand is why do we need input split? Because HDFS HDFS block is a raw representation of the data, while input split is the representation of the data in which we can say this is my record and my record has got these fields and so many input splits are there. Okay, so input split is a logical representation of the data, and input split is created out of the actual HDFS blocks. Okay, now as you can see here, look at this diagram. This diagram and this example is not same. Yeah, this example is different from the diagram. So here you see the block boundary starting from left. So let's say there is a file which contains total number of 11 lines. First first block contains first 4 lines and around 80% of the fifth line. The 20% of the fifth line is in the next block. This is the block number 1, block number 2, and block number 3. And you can see that block number 3, the last block is smaller because remaining data goes into the last block. All right. Now, if you see this line, if it is split into two parts, may not be very useful while we are doing computing. So we'll have to pick this particular line and try to get the remaining. So this 80% of the fifth line is on the first block and 20% is on the second block. So while creating a logical representation called input split, we will fetch the 20% of the data from another machine. This is another machine, this is another machine, this may be another machine. Okay, this may be another machine, but these are different blocks. So to prepare input split, the Hadoop will get this 20% of data from another node. Okay, and that's how you will get the full line in a input split, complete line in an input split rather than partial line. Now you can see that it's not strictly that there is no data transmission, there is a slight data transmission happening in this network. Make sense to you? Is input split clear to you? Vaibhav, Kiran, Deepak, Leonid, Matthew. All right. So therefore, we cannot consume blocks directly. Therefore, we create input split. Also, it also depends on your MapReduce program whether you want to consider the input data as record by record, or you want to consider it as key values, or you want to parse it as like fixed fields, or you want to consider the input data as JSON object. So it is up to the MapReduce. How does it want to process the input file, and how does it want to represent the input data? Okay, because HDFS does not know anything about your data. HDFS only knows about the raw representation, that is bytes. Now, MapReduce question is: does Hadoop do this for us, or do we specify input split? We specify the input split. Hadoop ships with lot of default input split kinds. Okay, we specify that okay, we are looking for text input. Like in this case, in our default case, our default case, there is something called text input split that we use. Here, if you see our driver, we have not specified explicitly, but we can specify our other kinds of input split. Okay, I'll show you that. All right. Next point is that's where the input splits come into play. So, a input split basically is a representation like you have got table or data set. Similarly, input split is a logical representation. So Hadoop divides input into splits. Hadoop divides input splits. Okay. Hadoop divides data into input splits, or you can say the MapReduce loads the blocks in the form of input splits. That makes more logical sense. One mapper instance per input split. So as we said, the map function will be called on each record, but the instantiation, as in not every time the mapper class is going to get created. The mapper object is created only once for each input split. You can always take analogy of an input split as it's a collection of records, or you can say that it's a kind of a table, it's a section of a table, and each record is like a row. All right, so input data is represented in the form of input splits. So split contains many records. Mapper runs uh, once on each record. Okay, mapper runs. So we have this map function which we had defined in our stub mapper. So this map function will get executed on each record. Now if we choose, we will have to decide our input split very wisely. Okay, although for most of the works which you are going to do in future, there is a default input split which you can use. Okay, but in case you are planning to create your own input split, you have to keep in mind that you in case you try to create input split which is very small, if your input split is very small and the block is really big, then what would happen is you will have to keep transferring lot of data from one machine to another. Therefore there will be a very high overhead. There'll be a very high overhead. So the good split size tends to be equal to the HDFS. The smaller the transfer, the better it is. But sometimes you cannot avoid it. Sometimes, sometimes you might have to process all the blocks in a single shot. Say for example, you are trying to compute the signature, say MD5 checksum or SHA-1 checksum. When you do a signature of the big file, you generally use any of these checksums. Now if you do any of these checksums, what you will have to do is you will need the full file. In that case, the block-wise processing, parallel processing will not make sense. Okay. Similarly, if you have stored the data in a zip format, to unzip it, you would require all the blocks. And therefore, in those cases, it would not make much sense to process it blockwise. All right. So input split contains records, and each record is processed by your map function. In our case, when we did the word counting, we used something called text input split. We used text input split, and in the text input split, each line was a record. Okay, each line was a record. So a record is basically a logical entity, and you can take the analogy of record with I mean RDBMS row. In your database table, you always have a row, right? So a record is equivalent to the row in RDBMS. Okay. So the input format creates the records and creates the input split. So we'll go into the details of input splits and go into the advanced MapReduce using Java in the next session. All right. In the next session, we'll go through all of these details. All right. Till then, please finish the assignment, the today's assignment as well. Even if you come up with your own strategies, okay. Uh, I mean, you will have to come up with your own strategies to solve the problems. All right. So please go through the problems, the MapReduce problem of the last session and today's session also. Today's session, the one where we are saying that next word recommendation you have to produce using MapReduce. All right. And whenever we are doing the MapReduce here, the next word recommendation, a solution which loads everything into memory will not solve the problem. There are many next word recommendation algorithms starting with R, and every other library provides you the next word recommendation. But the one you are going to do using MapReduce should be able to handle terabytes of data, petabytes of data actually. Okay. That is the most important aspect of this word recommendation. All right. Thank you very much. And do you have any questions for me? All right. Deepak, Kiran, Matthew, Vaibhav, do you have any questions for me? All right. Then have a great day. See you on the next weekend. Please finish all these assignments which we have talked today. All right. Please feel free to email. Yes, Vaibhav. Okay. Okay. Great. See you on the next weekend. Bye bye.